Welcome back to the channel, Risk Engineers. Today we have a great talk for you. We're going to talk to Stephen Fike of Assured NDT. There have been some major changes in regulations on infrared testing, and Stephen's one of the industry experts, so we're going to talk to Steve about it. Stephen, can you tell us a little bit about your role at Assured NDT and how your experience in risk management and electrical safety has shaped your approach to compliance?
Sure. First, thanks for having me on. Anytime to talk about myself or my company, I'm going to jump at, so I appreciate you. No, so I am a risk engineer, just like you, John, and we've had great discussions about what we do in our industry. And over time, I saw that there was a little bit of a need in our market for more electrical testing, more infrared thermography, which aligned with new regulations that we're going to talk about from NFPA. So we created a separate brand and entity called Assured NDT, which I'm the founder and president of, to provide those infrared thermography services to insureds and clients serving the risk engineering industry.
Awesome. You mentioned the regulations have changed. NFPA 70B has gone from a recommended practice to a mandatory standard. Can you bring us up to speed on that?
Yeah, so in 2023, NFPA 70B, which talks all about electrical preventative maintenance, had changed that a little bit of wording and frequency for infrared thermography from a recommended practice to what they actually call mandatory now. So this is pretty significant because it now establishes clear, enforceable requirements for electrical maintenance. From a risk management perspective, this is reducing ambiguity and ensures consistency with preventative practices. Obviously, the NFPA board has recognized that electrical fires are a leading cause of fire for industrial facilities, and they've set out to increase property and employee safety. And while not adopted yet by law, we see that AHJs are starting to enforce this, including OSHA or the insurance companies.
Sure. OSHA is going to have the general duty clause, which basically says if you're not following generally accepted practices, then you have to have some analysis or some reason for not doing that. If you're out doing your own thing, you have to have a basis for doing that. Can you talk to us? I know most of the risk engineers that watch this understand what our scans are, but we also have underwriters and we have some lawyers that join the channel. Can you give us a quick explanation of what IR is and how it works?
Yeah, sure. I really like to break this down at the layman level. And the way I explain it to people is it's an X-ray for electrical equipment. Now, this can also be used for other purposes as well. You looking at the building envelope, looking for different moisture and leaks. But primarily what we're concerned about, what NFPA 70B is concerned about, is electrical preventative maintenance. We are looking at anomalies, temperature differences within this electrical panels and equipment to understand if equipment is overheating, if it is deteriorating, which can lead to sparks, fires, arc flash, or equipment failure. So the whole goal that we're trying to do is preventative measure of understanding what's behind the equipment we see and how can we monitor that and repair it before something catastrophic happens.
I like that idea of x-rays for equipment because it really is. It lets you see what your eyes can't see. And I've seen it in reports, I've seen it with cameras, and it's just amazing. You can look at a whole rack of batteries in an offshore oil rig. And I'll never forget, they had the spare battery in the room. They knew one of the batteries was bad. They didn't know which one, but the IR camera showed them exactly which one was warm and needed to be replaced.
Yeah, it's always easy talking
So
to risk engineers like yourself who have seen it, who understand it, right? And it's about increasing the education for the general public now.
So let's talk about that a little bit about what the difference is between qualified personnel doing these inspections versus like I was doing it in the old days. I just went out and bought a Chinese infrared camera and took it around with me everywhere I went. I didn't know anything about emissivity. I didn't know anything about reflections. And I don't know that I was actually doing thermography inspections, but I was having fun looking through the camera. So let's talk a little bit about the difference between a company that buys a camera for their employees versus somebody who is looking for a formal program.
Yeah, thanks. First, let's talk about the equipment, right? It's a varying level of equipment, anything from the smallest unit, which might be a couple $100 and attached to your iPhone, to something worth $20,000. It depends on the application and the precision and accuracy that you want, right? So I think that's first. I think that when somebody is doing it on their own, it's very easy to think that they're looking at equipment right, but maybe not understanding that the equipment is not calibrated properly and doesn't possess the technological features that you need to really identify if there's a potential problem. So I think that's number one, and I think that's why I stress that while you can do this in-house, first you need to have the correct software and the correct kind of equipment and ensure that you're utilizing that and calibrating it properly. Second, then you have to look at, are these employees trained appropriately? And that's what we do with all of our in-house staff. A lot of risk engineers are familiar with looking at fire sprinkler systems, and they understand that in order to go out and test those sprinkler systems, you have certifications from NICET. You have NICET 1 and 2 and so forth. Infrared thermography is no different. There is national associations that have created these guidelines of thermographer 1, which is basic understanding, 2, which is a solid professional thermographer, to 3, a master thermographer and understands all the ins and outs of what they're doing and has several years of experience under their belt. We are working to ensure that people understand those differences and are utilizing certified, qualified individuals who can use the equipment appropriately to ensure that it's the most accurate results.
Great. So I get it now. We know a little bit about the equipment and about the people looking at the equipment. How do we decide what equipment gets looked at? So if somebody's trying to build a program from scratch and they know nothing about thermography, say we've got a gas processing plant and they want to create a list of what they need a company like yours to come in and look at. How do they decide what goes on the list and what doesn't?
I like a top-down approach. I think you start with the largest piece of equipment and move down from there. Especially with some of these plants, you can't all do it at once. They're operating 24/7, sometimes under load, sometimes not. So you have to coordinate a lot with them. And this might occur over several years of getting to all of their equipment. I think that every location is a little bit different. You really need to have a deep understanding of the technical aspects of that business to understand what their power needs are, where the power is coming from, and how it's used for different pieces of equipment. From there, you can understand the bottlenecks, the MCC equipment, and create a proactive program with them. For most commercial properties, really, you're looking at the transformer if it's owned by the commercial property itself. You're looking at some of the bus ducts and some of the switchgear components. But I really think that it differs all the time. And it's another reason to reiterate what we had just talked about, using certified individuals. And sometimes an outsourced company can help create that program for you.
Awesome. So I recall that an acquaintance at another at a utility would use the camera. He wasn't certified, but during refueling outages, they would have big motors shut off because they weren't in service. And they have heaters inside these motors to keep the humidity from getting into the motor. And it seemed like they didn't really need to know what the temperature of the motor is. They're not trending it from outage to outage, but they just need to know, is the heater on or not? And for a company that's looking for something like that, if they want to figure out, if you want to diagnose the health of a piece of equipment, it's just your blood pressure or what else. You want someone who understands what they're looking at for the important stuff, for the operational, but for something that's simple, is it warm or is it cold? Then maybe the pocket camera is appropriate. But if the facilities are operating, that gives you one piece of information. But if they're shut down, there's still information that can be gleaned from using the IR cameras. Now, there's a shift towards condition-based maintenance, and NFPA 70B requires closer monitoring of equipment status. How can engineers integrate IR scans into a broader predictive maintenance strategy without overwhelming their teams or their budgets? They right now overhaul equipment on a set frequency. How can IR fit in that process to maybe change the frequency that they're doing their overhauls?
Yeah, I think engineers can integrate IR scans into the existing predictive maintenance schedule by treating them as just one layer and a tiered monitoring strategy rather than just a standalone burden. So you can start by prioritizing critical assets. So you focus your IR scans on transformer, switchgear, and feeder with the greatest risk of impact, and then can move down to smaller pieces of equipment as you just talked about. You can combine this with other diagnostics, which I highly recommend. You integrate the IR results with vibration or oil analysis or partial discharge testing so that you are creating this holistic equipment health but also so you don't have so many third parties running around at the same time. It's easy to fit these individuals in during the normal preventative maintenance cycle. And then, of course, we outsource selectively. So we talked a little bit about the burden of this. We are seeing in the marketplace a very wide variety of different pricing and professionalism involved. So call around, understand who the experts are, make sure that you're getting the lowest cost. I have seen where there is a cost burden to some of these facilities, and that really should never be the case. Typically, the most I've ever seen so far might be 1% of the risk management spend is being dedicated to infrared thermography. And as you have a higher risk and higher total cost of risk for high hazard locations, that percentage is going down, down, right? I think as long as you are calling around using the right kind of individuals, you're really just not going to find a cost burden. And I think that every dollar spent in IR, you're going to get back 4 or 5 times.
Oh, yeah. Yeah, it's amazing. We've mentioned this X-ray concept that when you see a loose connection or dirty connection on a breaker, it narrows the work. You don't have to do an overhaul on everything. You only really have to overhaul what's starting to get warm. And you can plan for it way ahead of time before it fails. So that in itself should reduce costs as well. So, what about smaller companies now that NFPA 70B is becoming mandatory? What challenges do you foresee for companies or facilities adopting the 70B requirements?
As long as you're using a qualified third party, it's not too much of a burden. Again, you don't have to train up your own individuals. When you have a smaller hazard risk, let me take a very standard commercial building. It might only be $1,300 for the infrared scan. This is not, I would call, significant when you're looking at the overall premium. And all you really have to do is ensure the contractor has access to your facility so it's not upsetting any kind of operations. I think the biggest thing for these local organizations and why it's important for them is just to understand that even though that this isn't currently adopted by law, we are seeing a lot of AHJs start to adopt this in certain municipalities. A lot of insurance companies require this, and we don't want to be caught with the proverbial pants down, right? If God forbid something happened, like you had said, of looking in the policy that the mandate for different companies to perform this could invalidate their insurance program, or they could be responsible for employee health and safety if there's some kind of accident because they weren't conducting this. We see it certainly as much more of a benefit than any kind of burden.
Sure. I'll give you a little nuance to that. When drones first came out and I worked for utilities, they wanted to buy a drone to inspect their transmission lines. And the old way of inspecting the transmission lines were to have guys with binoculars and infrared cameras
Sure.
walking the ground. And I said, be careful about how much you survey because it used to take one guy could only walk so far in a day. Now this drone's going to fly 100 times what that guy could walk in a day.
Mhm.
And you're going to find too many problems to fix. And you're not going to have the budget to fix them, but you're going to have identified them. And that's going to be a liability that's just sitting back there waiting to rear its head. I would recommend that if you're going to start the program, build your list, but phase in your inspections so that you can chew what you bite off. Make sure that you've got the budget and the resources to fix what you're going to discover, especially on that first go around, because hopefully after a couple of years of having an IR inspector come into your plants, you're not going to really see the same level of issues as you might in that very first time someone looks.
I couldn't agree more. And I think that feeds back into what we had talked about having a qualified third party involved. One of the reasons why we try to be that third party provider is if you're an electrical company and you're offering this as a service, you almost want to find things wrong sometimes. You want to send them work orders that you can complete. And a lot of people haven't realized that there is a large variety in temperature differences and required maintenance. So you can have a piece of equipment that might have a temperature differences of 18 degrees Fahrenheit. And that really doesn't mean that it needs to be fixed at all. That's a priority one device according to NFPA. And that just means, hey, keep your eye on it. You can go up to, I think it's 36 degrees Fahrenheit before any immediate repairs are needed, right? Only when you really get over 40 degrees Fahrenheit or when you just need to start, hey, we really need to schedule this. And so it's having that third party who can explain that to you and then look at all of your results and prioritize them the way you said and said, all right, we need to start with priority 4. This is something that's going to be imminent loss ahead. This is over 70 degrees Fahrenheit different. And then we'll tackle priority 3. and maybe everything else within priority 2 and 1, we just monitor and make sure that those temperature differences aren't increasing more.
Let me ask you this. It would make sense. I know in the nuclear industry, we used to calibrate pressure gauge before and after we used it. If a thermographer discovers an issue and a maintenance order is put in and the work is done, would it be a good idea to come back and infrared that work again after or that piece of equipment after the work is done?
I always say best practice, absolutely. But is it necessary? No. So it goes back to the burden. If we've already been out there several times, if we know that we're on an annual subscription or semi-annual subscription, maybe we just wait for the other 6 months because it's brand new equipment. We want to tread that line lightly where yes, we want to help them with their preventative maintenance and be predictive, but we don't want to be overbearing. They have a business to run at the same time. And if you're installing brand new equipment that's certified by an electrician, at some point we have to trust that and we'll hit it on our next maintenance cycle.
It seems every conversation these days has the letters AI in it. Do you see any application
Right.
of AI, either in the equipment itself or in the interpretation of the results? Where are we going with AI and IR?
Sure, it's already being used. So one of the reasons we formed this company, Assured NDT, was because we saw the AI revolution and we realized, hey, we're still going to need boots on the ground for certain preventative maintenance and predictive analytics. So we wanted to be those people so that we still have a job in 10 years. But as far as the industry, you can take the results and you can see it at a camera. And a lot of times the camera will show different hotspots, but you don't know necessarily the severity until it's run through the software. So I would say the software that is really reading all the characteristics about the camera and the JPEG that you took is already some form of AI. This is doing automatic reading, it's creating these automated reports for you. And I see that advancing a little bit more within equipment of drones that you had talked about so that it can tell you right away and maybe alert you so you can stop and take a higher resolution picture of a certain area. I see that also for fixed cameras, where some of these facilities and certain high value, very important equipment might start having fixed IR scan or cameras just pointed at them, and that it could be tied into an alarm. So it's alerting the operator that they need to stop what they're doing or move forward with repairs, etc.
That's interesting. The call that I have coming up after this call is actually about fixed IR equipment inside of battery energy storage modules.
There you go.
And yeah, and I've written articles, proposed fixed IR at solar farms to basically keep an eye on the whole facility. Having a fixed IR camera or a few at a solar facility would help because a lot of times believe it or not, they've had fires and they didn't know it. The plant, the fire wasn't enough to damage a module, but some grass burned and fire department responded. They have a key to get in and they put the fire out. If they had their own fixed IR cameras there, it would have given them at least the night before warning rather than walk in the next day and see that they had a fire.
You were talking a little bit about the solar farms. As a risk engineer, I had visited 4 this past year. 3 of them had serious fires that took out about 50% of the solar farm each. Something I learned is it doesn't take a big fire, like you said. These were brush fires that had caught through some kind of electrical issue that had started, and there's enough fire and flames to affect the heat on the back of the panel to melt the wiring and melt the back casing that you had to replace the entire panels. Now, these are panels that are already elevated off the ground by 3 feet. They're on steel metal poles. You would think a little grass underneath wouldn't affect them, but it only takes a small fire. And to your point, these are often in the middle of nowhere. There's no kind of fire detection around, so no fire department knows about it. If they would have had fixed IR scans, cameras there, fire department probably could have responded much, much quicker, salvaged a large percentage of the panels. We're also seeing that in our industry, and I'm recommending that to people, even though I would love the business of flying a drone over their solar field once every year, a year or 6 months. It makes a lot more sense to have these fixed IR cameras.
Yeah. Shifting a little bit from electrical equipment, how about bearings and compressors? How about rotating equipment? Do you get involved with that much?
We absolutely can. When it's operating at load, we understand it's about looking at it over time and understanding, hey, here's our baseline, and let's track it over time to ensure that baseline is staying consistent and it's not heating up. I'm actually happy that you mentioned that because I know when you and I first connected, we were talking about lube oil pumps. And I was going to say earlier when we were talking about what's important for these different facilities, you have to really dive in to their individual equipment, understand what makes their plant tick, and then start to focus on those issues. So if an operator knows that a certain piece of electrical equipment or maybe even small motor, could be a low value motor, but that motor is controlling this lube oil pump or bearings, then of course we want to start putting this on the preventative maintenance IR scan. It's not about just whatever the highest value of equipment that there is. It's also understanding what pieces of equipment really power the main plant output and what kind of significant damage could occur if that pump fails catastrophically and the lube oil system no longer works.
Yeah, I think you're making a really good point for our risk engineers, and that is that you wouldn't hire a wedding photographer to come in and take pictures of your plant. You'd want to make sure that you hired somebody who understood where the risk was and what the significance of the equipment was, and a little basics of the process, fuel in, electricity out. And I think that's important, and it may distinguish one service provider in your industry from another, and that's the people who just are cranking out wedding photographers and turning them into thermographers versus someone who's taking risk engineers and turning them into thermographers. I think you'll get a different output or a different product when you're finished.
Yeah, couldn't agree more.
That is about the end of our questions, unless there's anything else you wanted to cover that we haven't talked about yet today. And definitely, I want you to give your contact information, and I'll put it up on the screen, but you can give it out as well if anybody's just listening to this. Hit us with your closing thoughts and your contact information, Stephen.
Hey, it's your podcast. I'm just happy to be here. So, long-time listener, first-time caller. Thanks for having me. No, our company is Assured NDT. We're a non-destructive testing company. We're focused on thermography, arc flash testing, and oil and gas analysis. You can find any information about us, assuredndt.com. There's a contact page. Please reach out. We are all risk engineers who are involved in the testing for large facilities, commercial properties to meet NFPA and OSHA standards. And hopefully we can work together soon.
It's awesome. All right. I really appreciate your time. You're helping a bunch of risk engineers who may get to read a thermography report every now and then. And it looks pretty, it's cool, but this hopefully tells them a little bit more about how to advise their clients on getting a program started. And to all my viewers and listeners out there, please share and subscribe. It helps the channel. And we'll see you on the next one. Thank you.
Thanks, John.